Welcome to this presentation about next generation cyber ranges. My name is Almerindo Graziano. I'm the CEO of Silensec. In this technical presentation, we will talk about the practical uses of next generation cyber ranges for testing cybersecurity skills and organizational cyber resilience. Besides working with Silensec, I'm also the co-chair of the European Cybersecurity Organization Sub-Working Group on cyber ranges and technical exercises. And I'm an expert with the International Telecommunication Union, and for many years I've been involved in the development and delivery of cyber exercises, and in the last few years also using cyber ranges for the delivery of such exercises. The content and the view expressed in this talk are not those of EXO, yet we invite you to download and read the paper published by EXO on understanding cyber ranges from hype to reality. Cyber Ranges is a vendor of next generation cyber range technology. Is available on premise, hosted, or through our public cloud as a service, and also available as a portable cyber range through 3 laptops. As a company, we are based in Limassol in Cyprus, and we deliver a lot of cyber range enabled services such as cyber exercises, cyber drills, red and blue team training, and competence assessment and HR recruitment services through the Cyber Ranges platform. We talked about next generation cyber ranges. Just to give a brief recap about it, a next generation cyber range is more than a traditional one. Traditional cyber range technology and products focus on purely the simulation aspects, so on providing the simulation environment for different use cases. When we talk about next generation cyber ranges, we really talk about an ecosystem of simulation environment and inbuilt and integrated functionalities that allow the use of such simulation capabilities for the delivery of different use cases, from cyber capability building to testing, organizational resilience to competence assessment, and many more. And the key component, the key functionality, or the core of a next generation cyber range is orchestration. And in this particular technical presentation, we will show how orchestration works and what actually orchestration means when it comes to cyber range technology. Let's look now at the power of orchestration. The key use case for orchestration, or how orchestration is used in next generation cyber range, is in the running of multi-user events. Now, when we talk about multi-user events, we are not talking about a platform that gives access to a number of users who can each, in their own time, have access to a simulation environment. We are talking about events where mostly the users can interact with one another, or at the bare minimum, work in parallel and compete with one another. And let's look at some of the examples. A classic examples, or becoming even more classic these days, is the ability to deliver red team versus blue team scenarios. And this is a classic multi-user event, because we have on the one side a team trying to attack an infrastructure, and on the other side we have the team trying to defend it. So it's very important to be able to very easily start a scenario which brings up the simulation environment which multiple teams can have access to. And one of the requirements that we want to meet is that we don't necessarily know, or need to know how many people the blue team has, or the red team has, or if there are multiple red teams and multiple blue teams from different departments. We just want to have a scenario, an event rather, where multiple teams can come together and engage with one another using a shared environment. And most important, I want to be able to do this without really spending a lot of time setting the environment up, selecting the team, creating the team, getting people to join the team, and then wondering which person belongs to which team. I want all of that to be taken care of by itself. I want people to just do what they want, as in, they join their own team, and then as a team they join an event. So that's a classic environment. A classic use case. Another use case for illustrating the power of orchestration is that of, let's say, competition. And when I mean competition, I'm talking about a range of use cases. Competition as such as, for example, CTFs, capture the flag events, or even the use case of competence assessment. I have 100, 200, 300 people that I want to put through a skills assessment, and I don't really know how many people will join this assessment or the specific names of these people. I just want to be able to invite a number of people to such an event and automatically start the skills assessment. Another use case is the delivery of cyber exercises. Again, even in this case, I want to be able to allow multiple participants to create their own teams and participate in a cyber exercises, giving me, the organizer, the flexibility of knowing that I have an environment, I have a simulation environment, and there is an organization with a specific organigram, with a specific number of security analysts, a specific number of penetration testers, and all I want to do is to start a scenario and deliver the cyber exercise, allowing the participant to engage freely without having to worry how many virtual machines I need to start. If a new user comes in and the team becomes larger, then I need to boot another system, and so on and so forth. So these are all examples where orchestration becomes very, very powerful. Okay, so let's get into a little bit more technical details, and let's show how orchestration works in practice. As we said, one of the typical use cases of using a cyber range is to easily create cyber exercises or scenarios for red team simulation, or to even have red team and blue team fighting against each other. In this particular example, we are going to look at a sample scenario which was developed for red team training. The scenario has a number of virtual machines, target systems, and the user is not able to see the specific number and types of systems, and that's part of the objective, to find out how many systems exist and the vulnerabilities, and trying to compromise the target organization. Now, let's say we want to run an event where we want to test the ability of a red team to compromise a target organization. So it's a red team type of exercise. And the easy way of doing this is to create actually an event. So we're going to call this red team assessment. We're going to call it a demo. And we want to make it a team versus team. The reason being is that I have a team of red teamers that I want to test. And I don't really know how many people there are in the team. I just know that they act as a team, and therefore they will all share access to the same infrastructure. I leave everything to default, and I'm ready to go. So I'm just going to click Create Lobby, and now the event has been created. Now, this is from event creator administrator viewpoint. So let's see what happens when a team joins this particular event. Now let's look at a user who wants to join this particular event. I see that there is an upcoming event called Red Team Assessment, and I decide to join. I want to join, and there is a specific start date, it's fine, so I'm going to join the lobby. However, it tells me that I cannot join the event because it's a team-based event. I therefore need to create a team. I can either join a team or create a team. I will create a team called Red Team. We hack as a motto. Country, we select Cyprus, and then we hack again as a team description. We also choose an avatar, and then we create the team. Here we go. Now the team is created. I can go back to the compete page, and I can now join the event. I join the event, and I will automatically be added to the list of participants for this particular event. Now, as you can see, the event has not started. I cannot join the particular event. Now, for the event to start, the administrator, in this case, Silensec, has to start the scenario. As administrator, I can now force the scenario to start. Remember, the scenario can be set to automatically start at a given time, but in this case, I can see that the red team has joined, and I can now force start. When I force start the event, then what will happen is that the user will see the start button is enabled, and they can now join the event. The environment is now being set up, and all we're left to do is to wait a few seconds before the environment is available and is presented to us for us to interact. Let's look now at another user who wants to participate to the same event, but as we know, and we have seen, the event has already started, so it's not going to appear here, but it's going to be available here. So we're going to click on here and decide to join the lobby. As we can see, the event is already running, the clock is ticking. We can now join the lobby. Let's join, and again, our team has appeared here, and we can now go to the lobby, and the event is already started. In other words, we don't have to worry about starting the virtual machines or the infrastructure, because this particular infrastructure is already available to the user. And as you can see, only one system is visible, the rest is part of the mission. Now, imagine to extrapolate this particular example to all the other use cases which you can think of, where the number of users participating in an event or having to interact with one another is unknown, and also where the complexity of the infrastructure environment that we need to replicate and set up on the fly is such that would require quite an investment of time and resources to do so. That's one of the first examples of the power of orchestration when it comes to next generation cyber ranges. But to really appreciate the power of orchestration, we have to look also now at the automatic attack or the simulated attacks, which can be delivered to a simulated environment through the power of orchestration, because that's the real difference, or the key difference between different type of cyber range technology. And to understand this, think about that the number of cyber ranges products out there are built integrated with public cloud providers such as Amazon, Google, or even Microsoft Azure. Now, these public cloud providers offer orchestration, native orchestration, and that's part of their service offering, because they need orchestration in order to facilitate the use and setup of infrastructure on the cloud. However, when it comes to tap into their orchestration to add automatic attacks and user management and scoring and reporting, that integration now becomes a challenge because the orchestration that was developed by the public cloud provider was not designed to support all such integration, but rather the more fundamental orchestration for the management of the virtual machines and the infrastructure devices. When looking at the power of orchestration, as we said, the challenge or the benefit rather of orchestration is the ability to automatically integrate attack simulation. And that's the main difference, or that's what differentiates what is an online platform for learning. So you where you may have a library of scenarios or a library of hands-on labs and a realistic simulation environment. And just to differentiate, while security training, competence building is one of the use cases of a next generation cyber range or a cyber range in general, it's also true and must be highlighted that scenarios simulating real life situation and attacks and cybersecurity incidents also make for an important part of competence building. Therefore, the ability to integrate attack simulation within a scenario makes up for a more realistic competence building when we talk about training, but it also opens up a whole range of use cases, such as that of testing cyber resilience and the ability of an organization to respond to security incidents, or even better testing of the abilities of security staff to deal with live event. Now, when we talk about attack simulation and the ability to simulate real-life attacks, the latest APT, one of the most common questions that comes up, or the comparison terms, is breach and attack simulation. Now, breach and attack simulation is a great technology, and it has been now around for a couple of years and has become mainstream as a security solution that organizations are using on top of traditional vulnerability assessment tools to better test the security baseline configuration of security controls within the organizations. And just so that we understand, a breach and attack simulation is a technology that is able to simulate the attacks or the activities of a real attacker and simulate, for example, advanced persistent threats or specific TTPs that are of importance for an organization to understand, if they are protected against. However, and one more thing to add to breach and attack simulation is they are agent-based. So they are usually agent-based, and through the use of agent, they are able to replicate and simulate the attacks carried out by a user. However, the main difference or key difference between the breach and attack simulation solution and the use of attack simulation within a cyber range is the equivalent of running a vulnerability scanning tool on a target network and pretending to call that a simulation of a real attack. The both vulnerability assessment and breach and attack simulation are aimed at identifying weaknesses and at the same time areas of improvement for an organization. So it is called breach and attack simulation, but the key objective is that of identifying gaps in the target organization that would allow a breach, and therefore serve a similar purpose, but to more depth than a vulnerability assessment solution. Now, within the context of a real scenario, or a scenario where we want to simulate targeted attacks, or we want to simulate the activities of an attacker, or a stealth activity, for example, or a fine-tuned series of stealth activities by an attacker, we wouldn't use a breach and attack simulation solution in the same way that we wouldn't use a vulnerability assessment to scan an internal network. For example, an attacker breaching an organization and gaining access to the internal network of the organization may not necessarily, and to begin with, run a vulnerability assessment. Because they may not have access to that particular tools on the target machine, but also because it will raise alerts. And that's why we don't use vulnerability assessment that way. Now, when we talk about attack simulation within a cyber range, we are talking about being able to recreate specific traffic, simulating users, web browsing activities, emails being sent, but we're also talking about simulating different types of attacks: network scans, vulnerability scans, system scans. And so for that part, yes, it would be similar to a vulnerability assessment. But we also want to be able to configure, schedule, and parameterize the specific attacks that are being run on the simulated infrastructure. And the reason why we want to do that is because we want to change ad hoc, depending on the objective of the scenario, the specificities and of the attack. In other words, we want to be able to run a very noisy vulnerability scan for let's say junior staff, to be able to identify a scan that is very noisy. Then we want to be able to run a little bit more stealthier scan up to a slow and anonymous scan. And the same thing we want to be able to do with all the different phases of an attack. In other words, we want to be able to change the difficulty and the type of attack in order to adapt to what it is that we are using that scenario for. This, while may be possible to a certain extent with vulnerability assessment tools and breach and attack simulation, what then becomes impossible or practically very, very difficult is the ability to automate the execution of such attacks and the simulation of traffic that goes into the simulated environment in a way that serves the purpose of the scenario. In other words, I want to be able to create a scenario where at the specific time, let's say 10 minutes in, there is an attack. 15 minutes in, there is another attack, and so on and so forth. And I want to be able to change that either dynamically, so live on the fly as an instructor, or I want to build it into the scenario definition so that when the scenario starts, it will automatically generate all those attacks. This is practically not possible to build by using a breach and attack simulation or a vulnerability scanner, even through complex scripting and integration, because the amount of work required would not justify the end result. So this is why breach and attack simulation and vulnerability scans, they serve a different purpose, and they are not best suited for use inside a cyber range and integrated in a simulation environment. And that's where next generation cyber ranges differ and show value, because they allow to integrate the orchestration of the simulation environment, as we discussed earlier, to ability to start, stop, reset, and automatically manage the deployment and the workflow of different simulation environment, together with the attack simulation traffic replay in a way that is automatic and click and play for the end user. Another consideration that always comes up when talking about attack simulation and with reference and within the context of a cyber range is attack simulation, legacy attack simulation solutions. This goes back to the primary use case, or the original use case of cyber ranges. Many years ago, a cyber range would be used, and is still used as a primary use case, as an important use case. Cyber range would be used for testing application system infrastructure, so perform, for example, stress testing, response to denial of service, and in the pre-cloud technology era, such deployment to be tested were actually hardware based. So an organization would create a replica setup of their infrastructure, and then they would use attack simulation or traffic simulation and stress testing appliances to be able to stress test and security test these replica infrastructure. That worked great for a long time, but it's ill-suited for today's world, because it's not flexible and requires a lot of setup. Imagine every time you want to recreate a simulation environment, you want to do a stress test or you want to do a test, you have to correctly configure both the hardware deployment of the replica environment and the simulator, the appliance that generates the traffic and the attacks. And if you want to change something, then yes, it may be possible to store the configurations, it may be possible to have some templates, but bottom line, it's all hardwired and requires resources to manage, configure, and run these simulations. And that's why, for example, even traditional vendors of attack simulation appliances are now today migrating to agent-based type of simulation, similar to breach and attack simulation, and they are leveraging their experience on traffic simulation to also bring it to the, let's say, the virtualized world. Many organizations that are looking at attack simulation and cyber ranges are still also looking at such traditional appliances. While there is value in the service and the simulation that they can produce, they are also not taking advantage of the flexibility, the orchestration that has been introduced by cloud technology. So in order to illustrate this and how the actual integration of the orchestration, so how the orchestration of both the simulation environment and the attack simulation come together, we're going to show you now an example of a scenario. The scenario we're going to demonstrate now is a scenario that simulates the defacement of a website. Now, the defacement of a website may in itself not be a complex scenario, but it's a good one to be able to illustrate the power of orchestration of both the simulation environment and the attack simulation that we were talking about. Okay, the particular example that we are going to demonstrate now is a website which has a number of vulnerabilities. Now, each vulnerability can be exploited in one of many possible ways. And what we have done, we have created a what we call in cyber ranges injection flow. Injection flow is a series of injections which, from beginning to end, produce a result. For example, we have an injection flow that exploits one of the vulnerabilities of the website, and then we have another different injection flow which exploits the vulnerability, which exploits the second vulnerability. And what happens is that the moment the user starts a scenario, these injection flows are timed to start at a certain time and to execute at a number of times and anyway until the vulnerabilities of the website are fixed. We begin with the website, which displays the website of an NGO, a national organization, and 5 minutes into the scenario, the attack begins and the user experiences a defacement of the website. Now, once the defacement has begun, the user has to begin the activity of fixing the vulnerability and re-establish from backup the original website. Now, the first point that we wanted to demonstrate is the automation of the attacks, and that is done through the injection flows, through the attack automation. And as you can see here, this particular scenario also has a curator SIEM integrated into it, and the user dealing with the attack is experiencing the real events on the SIEM. So there are real IP addresses from public IP addresses from around the world, and the ability to simulate stateful traffic, in other words, traffic that creates real events inside a log management system, is very important. Now, what I also want to be able to do, and that's the integration with the attack simulation in a cyber range that I was talking about, is I want to be able to also, as an instructor, vary the complexity of the scenario by injecting live events. And I can do so by easily adding events, which again can be either traffic replay or it can be a real attack simulation, like in this case it can be an Nmap scan. Or, and that's the interesting part, I also want to be able to add a new attack. So let's say, for example, there is a new attack or a new tool that has been published by an attacker that performs a more efficient or a stealthier SQL injection, for example, through encoding and trying to evade a web application firewall. Now, I can add that new tool into the library inside cyber ranges and create a new attack based on that tool. In this particular example, we are adding a simple one called SQL map, but it can be any type of tool. And once this tool has been added and once the template attack has been created, I can then make it part of the same scenario, so that next time I reboot the scenario or some other instructor reboots the scenario or some other team of people uses this scenario, they will experience the attack through this new tool. What I also want to be able to do is to not only replay the attack using this tool, but I also want to be able to change the options. I want to change the parameters. I want to use this tool a little bit different. For example, my team has now learned how to recognize this tool. It's written a signature to recognize the attack pattern. So what I want to do, I want to modify the tool is used. I don't want to rewrite the scenario. I don't want to remodify and reconfigure the whole thing. I just want to be able on the fly to just change the configuration and then replay the attack in such a way that the signature that my team has written is not going to work anymore. And I want to test how well they can spot this, and they can identify the new injection. So this is one example where imagine doing this with the integration of breach and attack simulation of vulnerability scanning, and imagine trying to script all the activities that I've just described in such a way that they are run automatically and that they are actually usable by anybody else that is using the scenario that I've created. So this is just one example with a number of use cases. But this is where the power of orchestrating, simulation environment, and attack simulation comes really to light. And that's where the beauty of next generation cyber ranges lies. Another similar example that we want to show you is integration with prevention solutions. So many organizations obviously are not just interested in detecting attacks and responding to security attacks. They are also interested in the prevention, the configuration, and the securing of the organization. In this particular case, we are using a Fortinet firewall. We've just changed and repurposed the scenario and changed the objective. In this case, we are focusing on the ability of a team or a security engineer to be able to respond to security attack and actually to correctly configure a web application firewall in order to stop the attack. Also in this case, the website gets defaced. However, here the emphasis is not on identifying the vulnerability. That's the role of the incident response team. Now the objective here is to configure the web application firewall to block the attacks while the vulnerability is being fixed and while a permanent solution is being found. Okay, we can see here the configuration of the appliance, and we can track how the user changes the configuration of the appliance in order to block the attacks. And the beauty of the attack simulation and the scheduling of these attacks is that they will continue to occur until the security engineer figures out how to fix the configuration of the web application firewall that will protect the attack. Now, combining these two examples that we've just looked at, we have seen a number of things. We have seen how a scenario, which is that of a defacement, can be used to test both response capabilities, but also defense capabilities. And now I can easily, through the configuration of the attacks, I can change the complexity of the scenarios in both cases, in both use cases, both for the incident response and for the defense. And I don't need to spend a lot of resources and a lot of time. I can easily do that with a click of a button, using the configuration that is being created and using the orchestration that brings together the simulation of the environment with the attack simulation. So this is really a great breakthrough compared to integrating hardware technologies, attack simulation appliances, and doing all these activities every time we want to run a scenario or every time we want to modify the scenario. So as you can see, the engineer here is trying to figure out how to block the attacks, is not succeeding at the first attempt. The website is still getting hacked, and eventually the security engineer succeeds, and he also able to see the logs of the attacks being blocked on the firewall. Now, while this demo is going through, it's also now important to understand that this type of simulation can be achieved and is achieved, and we have it for a range of attacks: ransomware, Active Directory compromise, lateral movements, privilege escalation, any type of attack that you can have in an organization, corporate infrastructure, can be simulated. And once it is created, it can be repurposed for different uses, and it can be adapted to change the complexity, the difficulty, and both live, i.e., I can change the complexity while the scenario is being executed by injecting live traffic, or I can change the scenario and make it more complex and create a different version that is targeting more experienced users. Before we close this presentation, it's important to understand that all the concept that we have outlined in this presentation are really about next generation cyber ranges. And cyber range technology really, as an innovation, follows a traditional curve for innovation, and that the technology triggers that have brought us to develop a next generation cyber range are two: cloud technology and attack simulation. Cloud technology introduces and makes available to the world the power of orchestration. Attack simulation introduces agent-based attack simulation, which integrated into a cyber range and orchestrated correctly allows the power of creating, running complex scenarios with just some clicks of a button. Now, after the examples we have presented, where we have seen the importance and the power of orchestrating at the same time simulation environment and attack simulation, you can easily understand how, using a next generation cyber range, you can easily develop a scenario such as this one, where we have a complex network, a corporate network, and a realistic scenario with real traffic and attacks being simulated, or even having live attacks with corporate security solutions, and where with the click of a button you can have multiple teams joining a cyber exercise and engage security staff in complex simulation without having to worry which machines to boot, which infrastructure to boot, or whether, if a new team joins, a new environment needs to be booted, and so on and so forth. And how, using a next generation cyber range, you can also develop something like this, where you have a world event with hundreds of users and hundreds of virtual machines with a complex infrastructure, which includes attacks, traffic, communication between teams. And this is exactly the type of scenario that we will be running with the United Nations this month as the World Cyber Drill, as Cyber Ranges hosts the World Cyber Drills, and a number of scenarios will be running on such an infrastructure. To conclude, using next generation cyber ranges and to implement such complex scenario with such large number of users and complex infrastructure, we can go from this to run an event to this. Thank you for listening and enjoy the rest of the conference.